All right. Hello, everyone, and welcome to Problem Decomposition and Pseudocode. So let's talk about the need for both of these things. Pull up a new whiteboard. So when we're talking about problem decomposition, it's really not too much more than it sounds like. You're taking a big problem and breaking it into smaller problems, solving the big problems by themselves, and then recombining those into one big solution. That's kind of the long and short of it. So this goes for actual projects and code and stuff that you write, goes for interviewing challenges, any of those things. First thing you're trying to do is figure out which smaller problems you can break this into. So there's one that I found online that I kind of liked that I want to do together. This one. An employee's weekly pay depends on the rate of pay and the number of hours worked per week. Employees work a minimum of 1 hour per week and a maximum of 60. An employee who works more than 40 hours is paid 1.5 times the normal pay rate for all hours worked over 40. Normal pay is, well, we're fixing that right now, $10 per hour. A program is required to calculate and output the weekly pay for any employee. Great problem. So this is one great big block. I want you to think to yourself for a second, if there are smaller problems you can, actually, hey, before we even break that down, let's restate the problem a little bit. What is actually being asked of us? We could solve like 13 different problems with the information they gave us. What are they actually asking for?
The amount of money someone made at the end of the week.
Yep. Someone, not the whole team. For any one person, how much do we owe them? And so based on that, what are we inferring? What's the input?
Hours worked by that person.
Exactly. So, so the input is hours, the output is dollars. And like in other ways that you do this kind of thing, you go any number of ways. We could say, all right, well, here's your 10 inputs and here's the 8 outputs that we need. Totally fair. But in this case, hours go in, dollars come out. So another way to think of that is that call this black box thinking. So we input hours and we output dollars, and what happens in between? To the outside observer, like the person getting paid, who gives a shit? For us though, since we need to implement this, it is entirely possible that inside of this, we have all kinds of other boxes that go into other boxes, go into other boxes, and combine to create that. Fractals all the way down. So our big challenge is figuring out first, what is the shape of the entire black box? What are the inputs? What are the outputs? And then we start decomposing it into what these smaller boxes are. So I want you to look at this problem and see how many smaller problems you can split that into. I'm going to give you 5 minutes, and I want you to Slack me all the sub-problems that you could consider in there. For example, how do I split all the hours that I'm given into regular hours and overtime hours. You don't need to solve them, just identify what the smaller problems are. 5 minutes, go. Oop, don't mind me. Just a sec. And we're back. We're having a good time. Oh, fuck, I crashed it. Open board. Plugged in my Sidekick monitor so I could read your responses and work everything. Fucking French piece of shit. Open the fucking thing. There we go. All right, and we're back. Start wrapping it up. Slack me what you got. Excellent job, William. Excellent job, Logan. Okay, cool. Lots of goodness in there. Let's do a little bit of it together. All right, so one that a lot of people picked out was the gimme. All right, so it's at least 1 and a maximum of 60. So I need to figure out let's see, how many regular hours, how many overtime hours? Right. That's one of the things we got to figure out. Someone give me another one.
What the overtime rate is?
Mm-hmm. So okay, it's given in the problem, but we can make the solution a little bit more generic if we parameterize those, would be the vocab term. What else? Other sub-problems. Once I've split my total hours into regular versus overtime hours, what do I want to do with each one of those?
Combine them.
Oop. Like you're skipping a step. Micro steps. I have hours. I need to turn that into regular dollars and overtime dollars.
You need to apply their respective rates.
Oh. That's it. Cool. So if I know the rates and I split the regular hours and overtime hours, and I can apply a rate really to both of them. One more smaller part of the problem. Logan, what is it?
Combine them.
Combine them. And one of you had this in your problem breakdown. I thought this was very, very sharp. So if we're doing math with it, like combining it, that implies that we're doing stuff with numbers. But these, when they show up like on your paycheck, they have the little dollar sign in front of it. Well, the dollar sign, we can't do, that's not one of our valid decimal numbers, right? So what's the last step of this?
Create a string with the.
or return amount. As a formatted string with that $sign on it. So like I've been doing this kind of stuff a while. I see something like this and it makes my eyes cross. Something like this, baby soft easy. So now let's move on to like the second part of this. So we're talking about pseudocode. Pseudocode is non-syntax specific descriptions of how you would do these kinds of things. So combining two amounts, well, this plus this. Applying a rate, well, this times this. This is gonna like involve some conditional logic, but we're not writing Ruby syntax, we're not writing JavaScript syntax, we're just describing the logical operations that happen. So there is a formal pseudocode syntax, which I think kind of defeats the point, but it looks like this. So that's formal pseudocode. That is like not super helpful, I think. But the things that are happening in here are, so identifying what the inputs are and identifying what the outputs are, I think that is helpful. I think that this is, I mean, it's supposed to be syntax agnostic. That's C syntax. So like, I don't think that that's quite as useful. If you just say loop through, or for every this in this, I think that kind of gets the job done. But you notice there's no curly braces. Even the parentheses, I think, are a little bit much here. Some stuff like accessing something in an array, I don't think that's so bad. Well, I get this for n thing. So that's like the formal way to do it. When people talk about pseudocode, they really just mean things like given amounts A and B, return A plus B. That counts as pseudocode. Or if we want to just talk through the logic, and that's a good way to think of it, how would you describe it in just regular English language? This one, how many regular hours versus overtime hours? How would I describe how the logic for that works in just regular language?
Less than or equal to 40?
Mm-hmm. So I could say something like, if, so say, given hours, if hours are less than 40, then return hours. Otherwise, you can say else, but if you literally wrote otherwise, that's fine too. Else what? What do we do if it's more equal to or more than, I guess that's another thing. If it's 40, the 40th hour isn't overtime. And so we really want this to be less than or equal to 40. Let's say that's not the case. What do we do?
Could you write another if statement saying if hours were over?
Well, they are. So logically, if this is the case, else means that that's not the case. So if it's not less to or equal than 40, then logically we know it's more than 40.
Would you be able to somehow return everything and subtract 40 from it?
Yeah, something kind of like that maybe. So we could say maybe something like return hours minus 40. Although this gets me thinking, how many regular hours versus overtime hours? Let's black box this. So the input is the hours. Think real carefully about this. What is the output? Single output. There's a lot of different ways we could do it. Pick one.
Well, could you think of like the single output would be any overtime hours? Because if they have overtime hours, then you can assume that they worked 40.
Yeah, I like that. So so now our input is hours, and we only want to get back any overtime hours. So we could start that the same way. If hours is maybe greater than, maybe we flip it around. If hours is greater than 40, return hours minus 40. Works for me. Otherwise, what do I do?
Are you just returning the hours?
Yeah. Oh, ooh, careful. So with this version of it, we're trying to find out how many overtime hours. So if it was less than 40 or equal to 40, how many overtime hours were there?
0.
0. Cool. So that gives me how many overtime hours I have. Now, the original problem we were trying to solve is how many of these versus how many of these. This will tell us how many of those, but we still haven't really solved that entire problem. What we've done how many overtime hours, that's this. So what else do I need to do? Another step in here. Once I know how many overtime hours,
You have to multiply those hours by 1.5.
so that's this step here, to apply a rate to the hours. I also need to know how many regular hours.
Just make a variable saying regular hours equals 40.
Potentially. So you tell me, if I can reuse this logic right here, let's say I have that in a function or a method or something like that. How can
So if you do like
that to help
if
me figure out?
hours are less than 40, return hours.
So that's going to be this thing right here. That's this statement I have. If the hours are greater than 40, so I'm already checking there. I don't need to check that twice. If I give this a name, like get overtime hours, let's see, how many regular hours?
Then you would do the opposite, right? If hours are less than or equal to 40?
We could. Probably don't need to, though, because I already have a lot of that logic figured out here.
From there, can you find what's left over?
Yeah, I like that. So represent how I would find out what's left over. Reusing some of this, or like if I just have this in a function called like get overtime hours or something. How can I reuse that to get how many regular hours?
So if that was a function, you could have a parameter of like total or something and subtract.
Yeah. Yeah, I like that. So we could subtract that out. So if I did something like get hours or get overtime hours, and I pass in the hours, so I can save that as OT hours. And then how do I use that again to get the regular hours?
Hours minus overtime hours.
I like that. Ta-da! So now I know how many overtime hours, I know how many regular hours. The rate given hours, and rate, return hours times rate. Cool. We had, what's the overtime rate? 1.5. What's the regular rate?
10.
Oops, so yes, so we'll call that regular rate.
The OT rate should be 1.5 times 10, right?
Yeah. How about times regular rate? I'm gonna put that first, but that's fine. Cool. So then our last little subproblem, return the amount as a formatted string. Given a number, what do I return on this one? I'm just trying to get the dollar sign.
Oh, just make a string?
Yeah, that's it. Something kind of like that. All right, so here is our pseudocode for this problem. Questions about it? Cool. So what I want you to do, I want you to make a new Ruby file. See if you can make this into some methods. Each one of these should be a separate method, and then you should have a method that kind of orchestrates all of them. So you should go into some new folder. Make a new Ruby file. You can call it anything you want, doesn't matter. app.rb. Open that up, make all the methods for it, and then you should be able to run ruby.apprb. See if you can use maybe some of that binding pry magic you've learned so much, make it interactive, and give it a shot. When you're done with this, I'm going to want to see your code. I'm going to give you, see, I'm going to call that 6 minutes. 6 minutes, see if you can get all this written out, regular code like, and slack it over to me. Go! Give you a little bit more time. Take another minute. All right, go ahead and Slack me your code. As a reminder, if you Slack something in what are called code fences, use 3 backticks on top of it and 3 backticks on the bottom. It'll make it look like code. Slack me what you got, even if you didn't get it finished. All right, let's talk about this a bit. All right, so here's mine. And it looks like this. This is, in fact, a little bit more verbose than I would probably do this, but this represents the problem decomposition. All these little slits that we made, little functions, little functions, little functions, barely do anything. And then we can kind of orchestrate them all together in one function that starts reading like a little story. We start with the regular rate and the overtime rate. We calculate the regular hours and the regular pay. We calculate the overtime hours and the overtime pay. We combine them into total pay, and then we format the result. And the way that we get it to work on the command line is we require in pry, and we put binding.pry in at the end. I saw a couple of you put binding.pry in the middle. So binding.pry stops the code. So if I put binding.pry there, it doesn't look at the rest of the code. It stops right there and pauses and lets me take a look at stuff and whatever else. But I don't have a get overtime hours yet. Actually, I probably do because this isn't a class, but careful with where you place that. It does make a difference. Also, keep in mind that I saw this one a couple times. Let's say you did something like def rates and put those in separately in here. Anybody know what happens if I run this method here? Tell me.
Does it overlook the regular rate because it's not the last line?
Correct. That's exactly what happens. If I call rates, I get the overtime rate back. This doesn't end up actually doing anything. I could make those two separate things. I could have a def regular rate like that. That's legit. If I delete those, I'll bet that still works. Let's try it. Ruby app RB. Calculate pay for 40 hours. How about 41? How about 39? Pew, pew, pew. Ask me some questions about this.
Can you scroll down to your format as dollars? That's one piece I didn't define.
Oh yeah, what am I doing there? Anybody recognize it?
Just interpolation.
String interpolation.
String interpolation. So I'm telling it to read amount as a variable. Otherwise, it's just in a string, and that $sign is just the character of the $sign. So when I make a string with that $sign character and also whatever the value of that variable is, string interpolation. I probably actually want to do something more like amount to fixed, I'm guessing it's called. It's called most languages. Ruby to fixed. Ooh, use that percent symbol. So percent dot to All right, I'm gonna give it a shot. Percent dot 2f as a string. Wait, is the percent one of their? No. And then I put in the actual thing. And then format that. I wonder if that will give me the 2 decimal places. Let's see. You're beautiful. Pretty cool. Ask me some more questions.
Is it always going to be best practice to break it down into smaller methods?
Yep.
Yep.
Even like this problem in particular is like right at the boundary of what I would start decomposing, but I would, if I were given this problem, I would still decompose it. It's supposed to be something that keeps you from making dumb mistakes. Not just like a thing you do because that's what engineers do. And so like I wouldn't do it needlessly. Like for example, I am being a little bit precious with something like that. But the formatting as dollars, I would absolutely actually write that as a separate thing. And I probably wouldn't break this down this far, but splitting overtime hours into regular hours, I would write that out. And anything bigger than this, like you're damn right. Because the thing is, you go, I can do that. And then, but unless you've actually like enumerated some of these things, either out loud or on paper, you don't hear little problems like, well, how do I split the overtime hours from the regular hours? You start, and if the problem is more complicated, you just start running in the wrong direction a lot of the time. So like pausing for half a sec to like figure out what some of the subproblems are is a very helpful step. There's a particular, if you want to know what like the hard mode version of this is like, there's a video on the site I'd recommend. Ahmed likes doing this shit where he gives me hard problems. Like, I have to fucking solve it in front of students. He stumped me last time. I wasn't able to pull it off. This is challenge. Ahmed and I started like trying to rewrite the little search algorithm for this so it doesn't take so long. Yesterday I couldn't get the code running on my computer. Walking through a real world code challenge, that's the name of it. So in this one, the challenge was given this like sequence of things, scramble it in a particular way. with like encoding them first and like a variety of other things. And then it gives you some samples for what it should look like. And like, boy, that was a toughie. And so what I did in it was just tried to make all of the little individual pieces of it as teeny tiny as I could and make each of those little functions, like turning a binary number into a decimal number, or turning a character into binary, or let's get closer to the end. Padding a binary number. That's like if something is 1, but it needs to be 8 characters long, put 7 leading zeros on it. That's what padding a number is. And so I wrote little teeny tiny tests for each of those, and then combined the ultimate result, and the problem was solved. That's like real life hard mode problem decomposition. Other questions?
Actually, I do have one.
Oh, you're a little quiet. What was that?
Sorry, I have one for the printing pay.
Yeah.
Whenever I use single quotations,
Yeah.
it won't print correctly.
Correct.
Is that just a Ruby thing?
That is just a Ruby thing.
Okay.
Well, like every language does that a little bit differently, but like in JavaScript, there's never any difference between single and double quotes. In Ruby, there is never any difference between single and double quotes except for formatting strings. If you want to use string interpolation, has to be doubles. Why? I don't know. They didn't ask me when they did it. And in JavaScript, this same thing, you can't do string interpolation in either of them. You actually have to use backticks. So this in JavaScript, and like the character for doing the string interpolation is also a $. So in JavaScript, it would look like that. Little syntax shit. You get used to it.
Speaking of syntax as well, the strictly equals.
Mm-hmm.
So
with JavaScript?
And well, in Ruby, actually, is there a difference between the 2 and then the 3?
I don't think Ruby makes a difference between those. JavaScript certainly does, but Ruby triple equals. Case equality operator. Oh, interesting. So triple equals in Ruby, that gives us multiple ways, overridable, like customizable ways that we can do equality on something. Don't worry about it. In JavaScript, this is like 101 stuff. In Ruby, that triple equals is like 601 stuff. I would just use double equals for comparison in Ruby. Other questions? Going once, going twice. Cool. This is especially good with like enumerable stuff, nested hashes, a lot of the stuff that you're working on right now. Try to make the problem smaller next time. See how it feels. Happy hunting. Cheers.